All right, here we go. Part 2. Here's the picture, and let's see what they've marked here. They say that this angle up top is 116 degrees. This is x. That's what we're trying to solve for right there, x degrees. They say this one down here is 72 degrees. And they tell you some important information. They tell you that this side is equal to that one, and this one right here is equal to that one right there. That's everything they tell you, isn't it? Let's go through it real quick because we still got some other things to hit here. First thing I would do is look at this. These two sides are equal to each other, which means this angle, right, it's isosceles, but it means as far as the angles that those two angles are going to be equal to each other right there. Agreed? If I knew one of these angles, if I knew this angle right here, this would be exactly the same. How could I find x if I knew this angle right here? I could add them up. That's right. Add them up, take them away from 180, and I've got this angle right here. But I don't know this angle, do I? Well, I know this one. It'd be really nice. Watch. If I knew this angle right here, it would be really nice because this one plus this one plus this one is 180. Agreed? So I could just add these two up, take it away from 180, and then that's what that angle is going to be right there. Then I'm good to go. Problem is, I don't know this angle. But I could find it, can't I? Because, look, I put two arcs here. Look at this. This is another isosceles triangle. If these two sides are equal, what's true about the base angles? They're both the same. They're both equal to each other right there. So if this is 116, how can I find both of these angles? Okay. Very good. Take 116 away from 180, and what's that? 64? Is that right? But does that mean this angle right here is 64 degrees? No. These two angles right here add up to 64. So how do I find it? Brett, you said it.
Divide it by 2.
Right. Divide both sides by 2. Or not both sides, but divide 64 by 2. Why did I divide it by 2? Well, it's because these two angles are equal to each other, right? And I just split it in half. Right, so they're both going to be equal to each other, right? So that's 32 degrees right here. And this right here is 32 degrees. Remember what I said? If I knew this angle, then I could find this one right here. So let's do this. Look at this big angle right there. You see that? That big angle right there? What's that equal to? It's 104. Why do I care that that's 104? Because now I can find this angle right here, exactly right. So it's 180 minus 104, which is 76. So this angle right here is 76 degrees, which means what? That's going to be 76 degrees. All right. Now I can find this angle up here. What do I do to 76 and 76? Add them up. So what is 76 and 76? Oops, 6, sorry. That's 152. All right, and then how do I find this? Very good. You're getting the hang of it. And then what's that, 28? Okay, so that angle right there is 28 degrees. Now look, I probably wouldn't have you do all that work just for one answer. What I'd probably do on a test is probably like, call this Y and call this one Z or something like that. All right, and then you actually get 3 answers. But to get X, it all depends on what you get for Y and what you get for Z, doesn't it? So you got to make sure if you mess up around here, it's going to mess your final answer up. And that's where it gets a little bit of a... You guys watching? That's where it gets a little bit tricky. So make sure that you do check to make sure you're getting these right in order to get that last one right. Okay, let's do one more type of problem. We'll look at number 18 and 19. All right, let's look at this one. The question just says find angles 1 and 2, but you might have to find a couple other ones before you even find 1 and 2. There's actually one of these angles is like the easiest. You don't have to do any math at all. Angle 1. Why is angle 1 the easiest? That's right. You got an isosceles triangle, and this is a base angle, and this is a base angle. What's true about the base angles of an isosceles triangle? They're equal to each other. So angle 1, whoops, angle 1, let's try that again. Angle 1 is what? 66 degrees. Just by looking at it, right? You don't have to show any work. There's really no work to show. You see that it's isosceles, the base angles are equal, so that's 66. Now you got to find angle 2. Now, this looks like a right angle, doesn't it? Okay, so just 90 minus 66, right? No, you can't assume that, okay? You cannot make any assumptions about that at all. So you can't just do that because there's not a little right angle symbol there. The reason I said that is because a lot of people will do that. All right, they'll look at it and say, that looks like a 90-degree angle. Let's just take 66 away from 90, and I got what angle 2 is. But you don't know that's 90, do you? Because there's no little square there. That's right. All right, so we got to do something else. What else could we do? Well, I got this as 66, and I've got this as 66. I probably could find angle 3, couldn't I? All right, so how do I find angle 3? I'll tell you what, there might be a little easier way to do this. I bet you we could find angle 4 pretty easy. Look at angle 4. This is the triangle. This is an exterior angle, isn't it? Okay, don't forget this theorem. This theorem, right, which ones are the alternate interior angles? No, not 4. 4 is the exterior. The remote interior angles to angle 4. 66 and 66. So what do you do with those two to find angle 4? Just add them up. No, don't subtract. If you subtract them, that would be 0. All right, so you add them up. So watch. That's 12, and that's what? 13. So angle 4 is 132 degrees. Let's write that in here. Oops, I can't do that. Let's just stick it right here. So what I say, that's 132 degrees. Now we could find angle 3 by doing one step. What would that be? You got it. 180 minus 132. And that's what? 48? Is that right? Yeah. So that's 48 degrees right there. Now, what about angle 2? I could do that, but there's another way. I mean, that wouldn't be wrong. You'd be right by doing that, but I could do it in one step. Look at this triangle right here. See this big triangle down here on the bottom? This is an extension of that triangle. Look at angle 48. I'll write it like that. That's an exterior angle, isn't it? To what? To 24 and angle 2. So in one step, just one step, how could I find angle 2? You got it. 48 minus 24. So 48 minus 24, and that's 24. So guess what this is? That's 24 degrees, and there you go. Say it again. I said no. I didn't say no. I said yes, you could that, but it's 2 steps. See, I'm showing you the most efficient way to do it. All right, I'm trying to make it the least number of steps that you could have to do. I mean, could you have just added those up and subtracted them? Sure, but I found this in one step, just right there. Actually, it wasn't that one. It was this one. Sorry, it was that step right there. Okay. And I'm just trying to help you out. I'm just trying to save you some time and effort, all right? But if that bothers you, if you don't like that exterior angle thing, and you don't really see it, you're not really sure what I'm talking about, then go ahead and just add 132 to 24, take it away from 180, and you'll get this answer right here. Now look, what was this angle right here to begin with? That's 60. That was a 90-degree angle, wasn't it? But could we make the assumption, though, that it was a 90-degree angle? No, you can't. You cannot assume that that was 90 to begin with, all right? Now, you might have gotten it right, but what if this angle was like 65 degrees and that was 24? It wouldn't be a 90-degree, would it? Okay? All right, enough of that. Would you say do that one with the distance formula? Okay, we'll do that real quick. All right, let's take a look. I want to show with this information why triangle TJD is congruent to triangle SEK. Well, if you look at it, the line segment TJ must equal what over here? SE, right? So TJ and SE must equal each other. So I could write not TE, TJ, right? So find out what TJ is and then find out down here what SE is, right? And then what else? What are my other sides? JD. So let's find JD. And what is my other side here? TD, right? So if I find JD, that would be the same as EK. If I find TD, that would be the same as SK. So what I'm trying to do is I'm trying to find the lengths of these sides. If I can show that TJ is actually equal to SE, then that's one side that's equal to each other, right? If I can show this second side equal to this second side, that's 2 sides that are equal. If I can show that this one is equal to this one, that's 3 sides that are equal. So if all 3 sides of one triangle equal 3 sides of another triangle, guess what's true about the triangles? They're congruent triangles, okay? So how in the world do I find the length of TJ? Distance formula, that's right. So what is it? Big square root. And I'll just do I'll just do one of these sides, and then you can do the rest. So you subtract the x's. Watch, I'm doing TJ, right? These two right here. So it's -4 minus 0. Don't pack up. Don't even look to your books. You sit and you watch what I'm doing right here. And then what's my y's? -2 plus 5, right? And then let's see what that distance is. We can do this in our head. -4 minus 0 is 4. 4 squared is 16. Plus, what's this? -2 plus 5 is 3. 3 squared is 9. That's the square root of 25, isn't it? Which is just 5. Come over here and do this SE. Watch. Square root. Put your parentheses and your squareds down. And let's see what we get for SE. It's -1 minus 3. And it's 3 minus 10. Is it 10? Yeah, it is. Alright, I made a mistake. Nobody cares. You're more interested in just leaving. No, that homework I'm going to collect tomorrow during the test, okay, before the test. So bring it tomorrow before the test. Let me just finish this up while everybody's leaving. So that's -7, right? And so that's 7 squared, which is 49.
And it ends up 65.
And that's 65?
Yeah.
Okay.
Same thing for the bottom.
So watch, that's the square root of 65. And this will come out to be the exact same thing. Alright, so those two are equal. So Jake, look up here. Jake, look up here. Jacob, look up here. Look, these two are equal to each other, right? You do the same thing. You do the same thing with this and this, right? You find a length, and you do the same thing with this and this. Well, these two sides are equal. These two sides will be equal, and these two sides will be equal.
Yeah.
So what do you got? You got side, side, side. Because you got 3 sides of
that
one
the only one
triangle.
you can
Listen to
get?
me. You have 3 sides of one triangle equaling 3 sides of another triangle. Yes, that's the only way you can do it by this method, because there's no way you can find angles by using the distance formula.
So like
The only thing you can find is the distance, is the length of the side.
So on the test, if when you give us a problem, if
Well,
I
the
have
answer
all the
is
sides equal,
the answer is either yes, side, 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 or just no.
all right,
All right, but I need to see.
I understand that. I know how to do all that.
This can't. I don't want to. I don't want this just to be a guess.
All right.
All right. I want to see why you
All
got
right.
it.
Oh yeah,
Okay.
just let you know if this